All right, guys, let's go over what we're going to do with lab today. So both parts of the lab can be found in Classroom. Um, if I go into our course 2 or course 1, it's in the same place under classwork. You will see the 3.1 mineral identification lab. And there should be, it's scheduled, but it'll post tomorrow. There will be a link to your copy of the lab as well as a link to the site. So go in this way. Um, like I said, if we have people that have forgotten their logins and passwords, if I'm not on, I will send a copy of them to Mrs. Maloof to get you on. But really, remember, you should be writing this in your planner so that you have it. Once you log in, you are going, oh, I'm not sure what happened there. This isn't good. Explore Learning. Log in. There we are. Home page. All right, Mineral Identification Lab will be the one that you will go into and you will launch it. All right, and then the lab's over here. And remember, the prior knowledge questions we're going to do before the gizmo. So suppose I find a yellow piece of metal in a stream. How could I tell if it's real gold? Well, remember that pyrite or fool's gold is much less dense than real gold. So I could find the density of the piece of metal and compare it to the known densities of pyrite and gold. So I can use density because density for gold, like we said, is always 19.3 grams per cubic centimeter, and pyrite is a lot smaller, has a lot is a lot less dense. In the city, a street peddler offers to sell you a diamond ring for $30. How could you test if the rock is a real diamond? Well, remember what? Diamond is the hardest mineral and can scratch anything. So by doing a scratch test, you would be able to determine if that was a real diamond. And so now we'll on the gizmo. Remember, the most important thing with the gizmos is you just follow the directions. So it says a mineral is a natural forming crystal. You can identify a mineral by its properties. In the mineral identification gizmo, under choose property to test, select density. So I'm in the gizmo. I come over here and I'm going to test density. Mass is the amount of substance in an object. Drag the mineral sample onto the balance. So here's my sample A, and that's the one I'm supposed to be using. Yes, mineral A. And what is the mass of the mineral? So the mass of the mineral is 36.4 grams. All right. Volume is the amount of space it takes up. So again, I'm going to take my mineral and I'm going to bring it over here in the graduated cylinder, and it goes from 40, whoops, oh, let's see, there we go. I guess you don't drop it in, you just bring it over. So it goes from, and let's see if I click on show, nope, that's not it. Oh, it says right here that it went up 14 milliliters. So right here, it's giving me the difference. And so I remember I have to convert it to cubic centimeters, so it would be 14 cc's or cubic centimeters. And in order to find density, I'm going to divide the mass by the volume. So if you have a calculator on you, which you should, otherwise use one in another tab on your computer. But I'm going to take 36.4 divided by 14, and I get 2.6 grams per cubic centimeters. And that's my density. And that's what you'll do when you're doing density for any of the minerals you're trying to identify. So now we're going to go on with activity A. Under the property, select appearance. So I come on here and I select appearance, and it says, minerals are made up of atoms in a repeating pattern and often form crystals. The shapes of the crystal can help to identify the mineral. Luster is another characteristic we can use. Remember, luster is the way that a mineral surface reflects light. Color can sometimes be a useful way, but not as always as reliable, because remember what we said about color, that a lot of minerals don't have a characteristic color, and many different minerals can be the same color. So it's asking you to describe the shape of sample A. So if I look at sample A, I would say maybe pyramid, because it has that pointy top, maybe hexagonal, because it has those different sides, though I only see 4. Maybe rectangle even. It's elongated. I wouldn't call it a cube, and it's definitely, I wouldn't necessarily say irregular. But again, when we're doing mineral identification, if you cannot easily see what the characteristic is they're trying to get you to see, try a different one. So let's describe its color and luster. I would say that it is whitish gray in color with a, I can't tell if that's metallic. Maybe it's metallic. It's not necessarily dull. It looks a little shiny, or maybe pearly. So we'll say with a pearly or metallic luster. All right, so then we're going to do the density. So we'll come over here to choose density, and again, we did that. So I don't really have to go through the steps of that, because our density is recorded up here. It's 2.6 grams per cubic centimeter. So I'm going to put that in. All right, hardness is a measure of how easily it can be scratched or can scratch. And so now we're going to choose the hardness property to test. And it wants me it says rub the mineral sample against each item, estimate the hardness. If the mineral leaves a scratch, it is as hard or harder. So if I go and I rub it against the fingernail, I leave a scratch, the penny I'm scratching, the steel plate, and I don't even have to scratch the glass, because if I scratch the steel plate, I'll scratch the glass. So we'll say that it has a hardness of greater than 6.5. I'm sorry. It scratched all the objects. It scratched all of the objects, and so we said it was greater than 6.5. Okay, now we can go to the streak test. Select the streak test. The streak is the color of the mineral's powder. So let's do our streak test. Here's my sample. I'm going to rub the streak plate with the mineral, and do I observe a streak? No, I don't. So it says, if the mineral is harder than the streak plate, which is 6.5, it won't leave a streak. So we'll write, that's not what I wanted to do. We will type no streak. Has a hardness greater than 6.5. Okay, select the acid test. So let's get our acid out. We didn't talk about this much in class, but remember, some minerals are going to react with hydrochloric acid. Let's see if ours does. Nothing. So I don't get any reaction. No fizzing. Now it's time to identify the mineral. Look at your mineral key, find a mineral that has properties that match, and then we're going to type the name. So let's come down here, and we didn't necessarily write the shape, but we'll start with what we know. I think density would be a good characteristic, and hardness would be a good characteristic. So let's come down here. And it says something that has a density around, was it 2.6? And a hardness greater than 6.5. So this is 2.2, but it's not very hard. This is 2.7, again, not very hard. This is 2.6 feldspar, and it does have a hardness of 6. We said it was greater than 6.5, so that might be, but there was no streak. So if we come down here to quartz, remember with feldspar I would have had a white streak, but I didn't have a streak. So quartz wouldn't be a bad option either, because quartz has a density of 2.6 and a hardness of 7, and it has no streak, and it has a regular or a hexagon shape. And so why don't we give quartz a shot? In my opinion, that matches the majority of what we had written down. So let's write quartz and let's submit. Correct identification. So we were right. So mineral A was quartz. And so if we come up here, so mineral A is quartz. And so as you see, just because we weren't able to, definitively say what shape the crystal was in, it doesn't mean that we won't be able to go forward and figure out what the mineral is based on some of the other characteristics that we're able to more definitively figure out. All right, so for that's I wanted to walk you through kind of what one of those looks like. We're going to basically do the same thing you did here for samples B through F, and then you're going to type your guesses, but you're not just going to randomly guess. You're going to look at what pieces of information you have, and then maybe, put a couple thoughts down. What properties did you find were most useful for identifying the minerals? All right, so you're going to work on part B. And if you have questions, raise your hand, but really, please try to just go through the steps and do the best you can to come up with answers, and use the mineral key to help you figure out what the mineral was. All right, guys, good luck.